Welcome back to Math 1500 Applied Business Mathematics at Connecticut State Community College. In this video, we're going to look at matrix inversion, finding the inverse of a matrix. First of all, if I think about inverse, like 3 times 1/3 equals 1. 3 and 1/3 are inverses of each other, or 1/3 is the inverse of 3. Similar is true for matrices. Matrix A times its inverse, or the inverse of matrix A times A, will equal I, the identity matrix. Okay. Now, not every matrix has an inverse, which is really kind of interesting. Those types of matrices, if it does not have an inverse, we call it invertible or a singular matrix. That will happen from time to time. It's not the purpose of this video to show you every single scenario that you might encounter, simply to show you how to find the inverse of a matrix. If you're finding the inverse of a matrix and you find that it does not have an inverse, then you'll know that that matrix is a singular matrix. So first of all, here's an example. The matrix 3, -1, 6, 2, and 1, 6, 1/12, -1/2, and 1/4. These are inverses of each other. Let's do the multiplication. Remember from our previous video how to multiply matrices. To find the element in the first row, first column, I multiply the first row by the first column. So 3 times 1/6 is 1/2. -1 times -1/2 is 1/2. For the, so that's gonna, let me move some space here. So 1/2 plus 1/2 is 1. Then to find the element in the first row, second column, we're going to multiply the first row times the second column. 3 times 1/12 is 3/12 or 1/4. -1 times 1/4 is -1/4 or 0. 6, now to find the second row, first column, I'm going to multiply the second row times the first column. So 6 times a -1/2 is -3. 2, whoops, I'm sorry, I did that wrong. 6 times 1/6 is 1. 2 times a -1/2 is -1. -1 and 1 and -1 is 0. To find the element in the second row, second column, I'm going to multiply the second row, 6, 2, by the second column, 1/12, 1/4. 6 times 1/12 is 6/12 or 1/2. 2 times 1/4 is 2/4 or 1/2. 1/2 plus 1/2 is 1. And notice that our resultant is the identity matrix. So I do know that those two matrices are inverses of each other. How do I find the inverse of a matrix? First of all, to find the inverse of a 2x2 matrix, let's say that that matrix is A, B, C, D. Okay, I find the inverse by, I'm going to invert the A and the D. They switch places. Notice the B and the C change signs. And then we multiply by the scalar 1 over AD minus BC. So let's use that up above. If I have the matrix 3, -1, 6, 2. Notice that A, B, C, D. 3 is the A, B is -1, C is 6, and D is 2. If I do 1 over AD minus BC, A times D is 6, BC is 6 times -1, so I subtract by -6, that's 1/12. Notice again that the A and the D change places, so the 2 and the 3 change places. B and C change signs. So -1 becomes a +1. 6 becomes a -6. 1 over 6 plus 6 is 1/12. 2, 1, -6, and 3. And now I have a scalar multiplication. I multiply 1/12 by everything in the matrix. 1/12 times 2 is 2/12 or 1/6. 1/12 times 1 is 1/12. 1/12 times a -6 is a -6/12 or -1/2. And 1/12 times 3 is 3/12 or 1/4. And that would be the inverse of that matrix. And notice that what we got here is what we had there as the inverse. So let's look at example 2. Same thing again. A is 2, B is 4, C is 1, 5 is D. 1 over AD, 2 times 5 is 10, minus BC. 4 times 1 is 4. So notice that's going to be 1/6. The A and the B, the 2 and the 5, they are going to switch places. The 4 and the 1, B and C, they're going to change signs. 5, -4, -1, 2. And now I multiply everything by that 1/6, so I would have 5/6 minus 4/6, that's -2/3. 6 times -1 is a -6. I'm sorry. 1/6 times -1 is a -1/6. And 1/6 times 2 is 2/6 or 1/3. And let me fix that first bracket. And so this is, if this is matrix A, this is matrix A inverse. That's how I find the inverse of a 2 by 2 matrix. To find the inverse of a 3 by 3 matrix, first of all, I'm going to augment the matrix. So notice I have 2, 1, -3, 4, 5, 0, -2, 1, 6. I augment that with the identity matrix. Then I'm going to do my Gauss-Jordan reduction. I'm going to reduce this to reduced row echelon form. This is all the row operations that we did back in the video 4.2, where we use matrices to solve systems of equations. So I'm going to do 1/2 times row 1, 1, 1/2, -3/2. That continues. 1/2 times 1 is 1/2. 0, 0. And you notice I did not leave enough room. I do those augmented matrix steps. Okay, you can go do that. If you don't remember how to do that, then you can go back to that video 4.2, using matrices to solve systems of equations. If you recall, what we did is we also learned in the calculator that I could put the augmented matrix into the calculator and do the reduced row echelon form. In this case, my matrix, notice, is a 3 by 6 matrix. I need to put in the whole augmented matrix. 2, 1, -3, 1, 0, 0. The second row is 4, 5, 0, 0, 1, 0. And then the third row is -2, 1, 6, 0, 0, 1. So there's my augmented matrix. I go back to my matrix math, and when we went down to option B, was reduced row echelon form for matrix A, we've got a mess. We've got decimals, so I'm going to press math, change to a fraction, and I'm going to change that matrix to a fraction, and you'll notice that the inverse here is the -5, 3/2, -5/2, 4, -1, 2, -7/3, 2/3, -1. And that is the inverse. Okay, so if you want to do the reduced row echelon form, you want to do the Gauss-Jordan by hand, you can do it. You can do it in the calculator. That'd be fine too. Okay, now I also have here using the graphing calculator because I could choose to do that. I'm going to make the 2, 4, 1, 5 my matrix B, and I'm going to make this matrix C rather than amending my A. So I'm going to go to matrix. I'm going to edit my matrix B to be the 2 by 2 matrix, 2, 4, 1, 5. So there's my matrix B. So notice what I want to find is B inverse. I'm going to select matrix B. Whoops, I don't want to do that there. my home screen, I want to select matrix B, inverse. Enter. Now I'm going to change that back to a fraction, and we have 5/6, negative 2/3, negative 1/6, 1/3. That's the inverse. Isn't that what we had up here? 5/6, negative 2/3, negative 1/6, 1/3. I can find the inverse of the matrix that way. So again, just because of the mess I have in my calculator, I'm going to put this matrix, the 2, 1, negative 3, 4, 5, 0, negative 2, 1, 6. I'm going to put that in for matrix C. So I'm going to edit matrix C to be the 3 by 3 matrix, 2, 1, negative 3, 4, 5, 0, negative 2, 1, 6. Quit. To find the inverse of that matrix, I need to remember that that's the matrix I put in matrix C. Inverse. Enter. Looks like the same thing we had before. It's a mess, because it's got the decimals, so math, enter. Enter will change it back to our fractions, and our inverse of that matrix is negative 5, 3 halves, negative 5 halves, 4, negative 1, 2, negative 7/3, 2/3, and negative 1. There's the inverse of that matrix. Why might we use inverse of matrices? Suppose I have a system and I want to solve that system of a matrix, solve the system using matrices. Again, back in section 4.2, we talked about using matrices reduced to an echelon form. We've used that in videos since then, like the applications 4.3. We used matrices to solve systems using the Gauss-Jordan elimination. Another option is I can set up what's called a matrix equation. Matrix A times matrix X equals matrix B. I can find the inverse of matrix A and multiply both sides by it. And again, remember that A inverse B, BA inverse are different, so I'd have to multiply in the same order. The inverse of matrix A times matrix A is the identity matrix. The identity matrix times matrix X is just X. And so X would equal A inverse B. It gives me another option on how to solve a system using matrices. And I've just got here example 6, a fairly simple system. What we've done in the past, we've done the reduced echelon form. We've set this up as the augmented matrix 2, 0, 1, 5, 2, 1, negative 1, 6, 3, 1, 1, 10. And again, we've set that up, put it in matrix A, reduced echelon form, which is still an option. Simply presenting you another option. Matrix A is the coefficients, 2, 0, 1, 2, 1, negative 1, 3, 1, 1. So that's matrix A. Matrix X is the variables, X, Y, Z. And then matrix B is the solution, 5, 6, 10. That's matrix B. And again, as we showed up here, X is the inverse of matrix A times matrix B. So, matrix A, I'm going to make my matrix A the 3 by 3 matrix, 2, 0, 1, 2, 1, negative 1, 3, 1, 1. So that's my matrix A. Matrix B is my solution matrix, that column matrix, 3 rows, 1 column, 5, 6, 10. Now, to solve for X, all I need to do is the inverse of matrix A times B. Matrix A, inverse times matrix B. Enter. And I get my X matrix is the matrix 2, 3, 1. In other words, X, Y, Z equals 2, 3, 1. So we have our solution that X equals 2, Y equals 3, Z equals 1. It's another option in solving systems of equations using matrices. It's called using a matrix equation. And like I said, I could use that as an alternative method. Personally, I tend to use the Gauss-Jordan elimination more often simply because it's less matrices, fewer matrices to enter into my calculator, but they're both good options. So again, I hope that this was helpful, and I hope that you are keeping up with the assignments in WebAssign. And if you have questions, you're reaching out. Thank you very much for watching.